Good morning, everyone. I'm here to represent the ISE2 activity of discrete mathematics. So myself, Akram Aslam Mujawar, my roll number is 2061 and my URN number is 21031073 and I am from batch S4. So my topic name is discrete probability. Introduction. Closely related to the concept of counting is probability. We often try to guess the results of game of chance like card games, slot machines, and lotteries. That is, we try to find the likelihood or probability that a particular result will be obtained. Probability can be conceptualized as finding the chance of occurrence and of an event. Mathematically, it is the study of random process and their outcomes. The law of probability have a wide applicability in a variety of fields like genetics, weather forecasting, opinion polls, stock market, etc. So now let's see the basic concepts. Probability theory was invented in the 17th century by a French mathematician, Blaise Pascal and Pierre de Fermat, who were dealing with the mathematical problems regarding of chance. Before proceeding to details of probability, let us get the concept of some definitions. Random experiment. An experiment in which all possible outcomes are known and exact output cannot be predicted in advance is called a random experiment. Tossing a fair coin is an example of random experiment. Sample space. When we perform an experiment, then the set of S of all possible outcomes is called sample space. If we toss a coin, the sample space S is equal to H comma T. Event and subset of a sample space is called an event. After tossing a coin, we getting head on a top is an event. Formula for probability of occurrence of an event equal to total number of offerable outcome upon total number of observations. Now let us see the steps to find out the probability. Step number 1. Calculate all possible outcomes of an experiment. Step number 2. Calculate the number of favorable outcomes of an experiment. Step number 3. Apply the corresponding probability formula. So now let us see the properties of probability. Number 1. If there are two events x and x bar which are complementary, then the probability of the complementary event is p of x bar equal to 1 minus p of x. Number 2. For two non-disjoint events A and B, the probability of the union of two events is P of A union B equal to P of A plus P of B. Number 3. If an event A is a subset of another event B, that is A is subset of B, then the probability of A is less than or equal to the probability of B. Hence, P of P is subset of B implies P of A is smaller than P of B. Tossing a coin. If a coin is tossed, there are two possible outcomes, head or tails. So total number of outcomes equal to 2. Hence the probability of getting head h on top is 1 by 2 and the probability of getting a tails on top is 1 by 2. Throwing a dice. When a dice is thrown, 6 possible outcomes can be on top. 1, 2, 3, 4, 5 and 6. The probability of any one of the number is 1 by 6. The probability of getting even numbers is 3 by 6, that is 1 by 2. The probability of getting a odd number is 3 by 6, that is 1 by 2. Taking a card from a deck. From a deck of 52 cards, if one card is picked, then find the probability of an ace being drawn and also find the probability of a diamond being drawn. Total number of outcomes equal to 52. Outcomes of being an ace is 4. Probability of being an ace equal to 4 by 52, that is 1 by 13. Probability of getting a diamond equal to 13 by 52, that is 1 by 4. Now let us see the problem statement. Two coins are tossed 700 times and the results are two heads is 205 times, one head is 3 to 5 times, no head 170 times. Find the probability of each event to occur. Solution. Suppose that the event of getting no head, one head and two heads by E1, E2 and E3 respectively. P of E1 equal to 170 upon 700, that is equal to 0.24. P of E2 equal to 325 upon 700, that is equal to 0.47. And P of E3 equal to 205 upon 700 that is equal to 0.29. So lastly, I want to thank for listening my video presentation. Thank you.